students, welcome back to my channel. In today's video, we are going to learn type number 14 related to Laplace transform. So what is basically that type? Laplace transform of derivatives. So to understand this type, you have to remember three important formulas related to this. So coming to the first formula, what is written over there? Laplace of f dash of t. Laplace of f dash of t can be given by s into Laplace of f of t minus f of 0. You have to observe this three formula very carefully. With the help of this formula, we have to solve problem based on type number 14. So to understand this type, let's consider one example. So what is given? Given is what? F of t is equal to t plus 1, where t is in between 0 to 2, and the second function f of t is equal to t, where t is greater than 2, and with the help of this given data, we have to calculate Laplace of f of t, Laplace of f dash of t, and Laplace of f double dash of t. So as you know that how we are going to calculate Laplace of f of t? By simply applying standard definition of Laplace transform. So let's begin with the solution part. We have to calculate Laplace of f of t. As you know that by definition, Laplace of f of t is nothing but equal to integration of 0 to infinity e raised to minus st f of t into dt, if you remember. Am I right? So in this particular case, there are two functions. We have two functions with us. So this 0 to infinity integral is divided into two parts. So the first interval should be from 0 to 2 e raised to minus st into, what is the value of f of t given? It is t plus 1 into dt, plus the second interval is from 2 to infinity e raised to minus st, f of t in this case is 3 into dt. I hope you have understood till this step. Next procedure is what? We have to apply integration. So if you observe carefully, you have to apply integration by parts. So according to the Liat rule, this is u and this is v. So as per the integration of u dot v, u as it is into integration of v minus double integration of v into derivatives of u. Am I right? So you need to apply integration by parts. As I said, t plus 1 as it is into integration of e raised to minus st into dt minus double integration of e raised to minus st into dt into derivatives of t plus 1. This is the first part, and then you have to substitute upper limit minus lower limit, plus you can take 3 outside the bracket. What is the integration over here? It is e raised to minus st by minus s, substitute upper limit minus lower limit. As you know that integration of e raised to minus ax is nothing but equal to e raised to minus ax upon minus a. Similarly, in this case, it is t plus 1 e raised to minus st upon minus s. If you are going to take the double integration of this, you will be getting e raised to minus st upon s square into derivatives of this particular term with respect to dt is 1, and then substitute upper limit minus lower limit. So if you are going to substitute upper limit minus lower limit, if you are going to substitute upper limit minus lower limit, what you will get? Next step is 3. Here instead of t we have to substitute upper and lower limit. So it will become e raised to minus 2s upon minus s minus e raised to minus 2s upon s square. This term is upper limit minus lower limit. If you are going to substitute t is equal to 0 here, you will be getting plus 1 upon s, then minus of minus, again it is plus 1 upon s square. Here, as I told you, this is upper limit minus of minus. It will become plus, minus of minus plus. So here you will be getting plus 1 upon s plus 1 upon s square. Okay, what is remaining? Plus 3 into upper limit minus lower limit. If you are going to substitute e raised to minus infinity, this term will get cancelled. Minus of minus plus e raised to minus 2s upon s. I hope you have understood. You need to check. You have to substitute the upper limit minus lower limit, and you have to check whether you are getting the same answer or not. So what would be the next step? Here you will get minus 3 e raised to minus 2s upon s minus e raised to minus 2s upon s square plus 1 upon s plus 1 upon s square plus 3 e raised to minus 2s by s. This will get cancelled. From this you can take plus 1 upon s square outside the bracket. What is there inside? 1 upon s plus 1 upon s square inside the bracket 1 minus e raised to minus 2s. So the Laplace of f of t is equal to 1 upon s plus 1 upon s square inside the bracket 1 minus e raised to minus 2s. I hope you have understood how to find out Laplace of f of t with the help of the standard result. But the second term is what? We have to calculate Laplace of f dash of t with the help of this formula. What we need to do? With the help of this formula, we have to find out Laplace of f dash of t. So let's begin with the second part, that is we have to calculate Laplace of f double dash of t. So Laplace of f dash of t, which is equal to s into Laplace of f of t minus f of 0. So we have Laplace of f of t value with us. Simply you need to substitute 1 upon s plus 1 upon s square 1 minus e raised to minus 2s minus what is f of 0? The given function is f of t is equal to t plus 1. What is the given function? F of t is equal to t plus 1. So if I substitute f of 0 in this, so what will get? F of 0 is equal to 1 plus 0. So f of 0 is nothing but equal to 1. If you consider this part, as t function is not there, so f of 0 is equal to 1 in this particular example. So you have to substitute f of 0 is equal to 1. So what you will get? 1 plus 1 upon s 1 minus e raised to minus 2s minus 1. This one and this one will get cancelled. The Laplace of f dash of t is equal to 1 upon s inside the bracket 1 minus e raised to minus 2s. I hope you have understood how to calculate Laplace of f dash of t with the help of this formula. Similarly, now we need to calculate Laplace of f double dash of t with the help of second formula. So what is given? Laplace of f double dash of t is nothing but equal to s square Laplace of f of t minus s into f of 0 minus f dash of 0. Now just now I told you f of 0, that is f of t, is equal to t plus 1. F of 0 is equal to 1 plus 0. If I need to take f dash of t, what is f dash of t, which is equal to 1 plus 0? So what would be the value of f dash of 0? It is equal to 1. So simply you have to substitute first the value for what? Laplace of f of t. So which is nothing but equal to 1 upon s plus 1 upon s square 1 minus e raised to minus 2s minus s into 1 minus 1, which is equal to, if you are going to open this bracket, you will be getting s plus 1 minus e raised to minus 2s minus s minus 1. If you observe carefully, this will get cancelled, plus 1 minus 1 will get cancelled. So the final answer is minus e raised to minus 2s. This is your final answer for Laplace of f double dash of t. I hope you have understood how to apply type number 14. So under type number 14, you have to remember three important formulas related to Laplace of f dash of t, Laplace of f double dash of t, and Laplace of triple dash of t. I hope you have understood this type. Please do like, share, comment, and don't forget to subscribe my channel. See you in the next video. Thank you.